Okay, I'm going to kick off. Welcome to the Winter Maize Workshop at the Foundation for Arable Research. I'm your host, Megan Cushnahan. Thank you to everyone that's joining us today. If you have any questions during our presentations today, we are going to take the questions at the end, but feel free to use the chat function during the presentations, or maybe put your hand up as well, and we will ensure we get to your questions. The first speaker I'd like to introduce today is Mike Turner from Corson's Maize. Mike is Corson's National Senior Research Agronomist, and he's here to talk to us about controlling the controllables. Over to you, Mike.
Good afternoon. Afternoon all. Thanks for letting me be a part of this. And we'll just jump straight in. I'm going to share my screen. I think I've got the right one. No, that's the wrong. Hopefully you can all see that. Right, so modern maize. It's a very real thing now that modern maize is becoming quite expensive to grow. The costs over the years haven't gone down. That's a very obvious statement, but in some cases they've doubled. So it's a good chance to sort of look at the costs we do have in our maize system and understand what they do, and also understand that we can't necessarily not use it because we need to protect the crop more than ever when input costs are high. The key line here being the cheapest crop is not always the lowest cost crop. It's the crop that converts inputs to value. And so yeah, we're going to explore a bit of that going forward. How do I go forward? For those of you who don't know who I am, thanks. I'm Mike Turner, so I'm National Research Manager for Corson Maize. I head up our product development group. Again, I'm very lucky to be able to travel the country and look at a lot of maize systems in my development role. I look beyond, I guess, just the yield potential of a hybrid. I'm looking for how it performs in multiple different environments and where that fits for a grower. You know, we all like to have big numbers and produce big yields, but hybrids don't work everywhere. So I spend my time finding a hybrid that works across multiple different challenges. But my ultimate goal really is providing practical and a safe, consistent pathway to a high performance for a grower. I think, you know, around the country, every grower has challenges, and I like to try and find ways that I can help reduce variability and a more consistent result, which isn't always going to be the highest. It's just going to be the most consistent. So the game of averages always wins. One good year doesn't negate four poor years. It's more about having 5 above average years in a row, in my opinion. So today's key messages are: with a maize crop, costs are value. You know, you're protecting the crop's yield, the quality, or its risk. You know, you analyse your cost. If it's going to protect any one of those things, it's a great investment. If it's not doing that, that's when you should start challenging it. Doing the basics right, you know, in an environment where you are growing a high cost input crop, getting those basics right is more important than ever. You know, that's coming along to measuring your fertility and applying the right amount of nutrition, fertilizer. You can't manage what you don't measure, so knowing what you've got before you start spending on it is the key. And I'm also going to talk about a little bit about CRM. And so in my travels, you know, a good discussion around maize is that, you know, the longer the hybrid's maturity, the higher the potential yield of that hybrid is. And while there is truth to that, the counter argument is that there's a lot more risk, especially in environments that can get dry or disease pressured. So I've got a bit of data to sort of show around that. So yeah, when you are spending on your maize, you've got to make sure you're spending deliberately and not, you know, fooling yourself that you can do the same as last year and expect a better result or even the same result. We need to sort of be very deliberate and very measured in what we do to ensure we are getting a good, consistent result. So yeah, here it is. This graph shows a trend over the last 5 years. So on the left-hand side there, the blue line being the cost in general of a maize silage crop, and the orange line being a maize grain crop. Now, obviously, grain crops require less input because, you know, the nutritional requirements aren't as high as silage. Silage being cut and carry, whereas grain, you're putting a good part of that crop back into the soil. But the key message being that the costs have gone up around, I think it's around 30%. Yeah, 30%. So, you know, that's a very real cost, and it's not going to come down in a hurry. Yeah, so in this situation where the costs are going up, you need to really protect the return you're getting from that investment. And that doesn't come from trying to skimp on a fertilizer if you want to try and save a couple of $100, because that couple of $100 you might save at the start might cost you thousands at the end with a lost yield potential. Yeah, so I guess the crop needs to earn its inputs, and that's what I mean. Like, you got to protect that investment, protect that yield at the other end, because yeah, savings up front often does result in a very poor result. This is a breakdown, I guess, of the biggest cost increases. So the top two for both silage and grain being cultivation, you know, your establishment and your fertilizer. Yeah. So, and this is I guess where the biggest savings, I guess, they can be seen as an upfront. You know, if you don't do that final power harrow, or you don't roll it if it needs it, if you don't spray the pre-emerge or post-emerge spray, you know, you've spent all that money and you've done one thing poorly, and you've pretty much compromised that entire spend from the start. In a rising cost environment, those basics, those very basic spends are more necessary than ever. So what's that showing? Roughly now it's just over $5,000 for on-farm maize silage crop from start to finish, from spray out to covering the stack. Obviously, it's not a fixed number; that'll be different for everyone. This is just a number I've sort of worked on, and based on my budgets and my gross analysis. But this is where, you know, that fertilizer price has gone up. You know, the cost of a soil test all of a sudden is very, very cheap. Because if you're getting your fertilizer spend wrong and putting the wrong amount of fertilizer on, or too much, or and some probably worse to put not enough on, you really are pulling the rug out from your crop from day dot. So you can't measure what you don't measure. Manage what you don't measure. Measuring is important, and those big tick items need a very clear role in that crop's pathway to a good result. Hope that's all making sense. Another perspective, and so when you do get the basics right, you know, a higher yield dilutes your costs. So on the right-hand side there, you'll see a 17-ton dry matter crop. On farm, it's 31.9 cents at that current value, but if you get 25-ton, you drop that price down to 21.7 cents per kilogram of dry matter. And so getting the basics right, measuring everything, and setting that crop up from the start, your fixed cost is diluted by the end result. You know, the increased yields take your price per kilogram of dry matter down. You know, most of the costs in a maize system are fixed. You know, you can't really adapt them as you go through. So the only real way you get to actually offset that is to produce that extra yield to make sure that you are on track for a good, consistent result. That's a pretty straightforward slide, that one. So we'll carry on. Again, for grain, so, you know, again, the costs are fixed. So every ton, I think you move from 12 to 14 ton, you make another $1,000 on your investment. So yeah, really making sure that you're getting the start right carries you into a better position at the end to make more money out of that system. Yeah, probably a pretty straightforward slide there as well. I'll give it a bit longer, but there's not too much more to talk to on that. But that brings me into the next sort of part of the thing, is managing risk, and part of that risk is CRM. So this graph here shows the trend of your maize yields moving from super short MG0. So for me, that's anything sub 85 CRM, right the way up to maturity group 5, which for us is anything above 110 CRM. Now, as you can see, the silage one is a more linear track. The longer the hybrid, the higher the yield potential is. But when you're in a grain system, you hit 100 CRM, which is NG3, 100 to 105 CRM, that yield really starts to plateau off. And then any point from then on, your risk is a lot higher than your potential return. Well, it can be a lot higher than your potential return. You know, some of these hybrids around 100 CRM are producing yields that are matching, if not exceeding, MG4, which is MG4 being 105 to 110 CRM. So anything above MG3, in my opinion, in certain environments, is a lot more risk than it's actually worth. Obviously, there'll be caveats to this. I mean, I'm not disregarding the fact that I've seen some 109 CRM crops do 20 tonne of grain. That happens very rarely, but it can happen. But you've got to really weigh up how often that happens and whether it's worth carrying that risk in your system, and then whether the payoff's actually there, because if it does come dry, those longer hybrids are the ones that can be severely affected and really, really bottom out under stress points at the end of its life cycle. So when you are growing, when you're looking at your maize system and deciding what you're up to, you know, CRM really does need to be looked at, and the history of your yields, and you can go back and look at your stress points and whatever. You know, you really do need to consider you are growing the right CRM or the right hybrid for that block. Otherwise, you're putting, you know, a high cost system and a lot of risk for no real return. And this is just, I guess, another way to look at that that previous graph. You know, the bottom one being your grain accumulation per day, it really drops off after your maturity group 3, 100 CRM roughly. Silage drops off too, but doesn't drop off quite as quick. So yeah, more days in the ground doesn't necessarily mean more yield. It can, but it can also be a high risk, very high risk adventure. So yeah, and you know, a shorter CRM is not about giving up yield potential. It's about providing a more reliable return and a less risky yield in the system. And again, so where it helps, you know, if you're in an environment where you've got typically a wet soil, you've got a later planting, you know, shortening up gets you established easier, gives you a better harvest window at the other end, gives the hybrid a chance to express itself and dry down rather than having to crash down if it's under pressure, or if you're looking at another crop behind it to sort of add to your income with that paddock. You need to avoid CRM by habit, and I see this all too often that they've always done it, so we're just going to carry on doing it. When you start asking some pretty challenging questions, pretty quickly, some people realise that the habit is actually costing them money, and they haven't really thought about that risk above 100 CRM or whatever they're growing. So, you know, spend the time. All the seed suppliers have all the information you need to make a really, really good choice. And I would just really suggest that you ask the questions of your seed supplier to make sure you are doing the right thing by your system. It's not going to be the same for everyone. There are a lot of systems that can easily grow long hybrids and they get the return out of it, and that's fine. But it's just worth really asking that question. Is your system built to handle that? Can you carry that risk? And what's going to happen to me if that hybrid does bottom out when it's dry, late, and I can't get there with the harvester? So yeah, again, just choosing the hybrid with the safest path to a grain yield is by far the best thing to do. This is some international quotes I found, and this is, I guess, backing up what we think in New Zealand. Don't chase it by habit. Just because you're doing it now doesn't mean it's the right thing to do. Protect that committed spend. That's really, I guess, a key point. You know, protecting that committed spend by making the right choices is a no-brainer. And you're managing for a finish, not just the start. So this is a mistake that's commonly made. Everyone thinks, you're planting for the now. You're actually got to realise that the crop's in the ground for sometimes 6 months. And so understanding, what's happening in February, March, April, what your stress points can be. If you've got a light soil, you're prone to go dry. You need to have a lot of stuff happened and finished by then so you don't risk that crop not maturing or developing properly and costing yourself a lot of yield. And so, understanding that when you're making the plan, you're actually planning, you've got to have a crystal ball per se, but you're managing for 6 months, not just for the planting period. And that's overlooked more often than you might think. And also a useful thing is to say you're not trying to grow the cheapest input crop. You're trying to sort of spend your money to make sure you are extracting the most value out of what you are looking to spend. Hybrid choice and population, so another risk mitigation tool. Again, your seed suppliers have all the information you need to make a really justified choice here. But when you are looking at it, population isn't just a number on a bit of paper. There's a lot of work that goes behind that, and it's a resource allocation kind of tool. The amount of plants you put into that field has a finite amount of resources that you're either going to have to spend to put into it, or it's available in that paddock anyway. Understanding what those resources are and having the right amount of plants to actually capture the best out of that, it's the best way to go. But you can't go too low, obviously. Low population risk, not enough plants, you're losing yield. High population, you're overcrowding, you're risking that crop crashing due to lack of water, nutrients, whatever that limiting factor is. If you're too high population, you're not going to catch it. And looking for hybrids that are adaptable or can flex. That's a whole different conversation in itself, hybrid flex, but hybrids that are very adaptable and can sort of manage to be to capture the yield if the conditions are right, but also if the conditions go the wrong way, having less plants to fight for that finite resource is a great tool for you, and it's a great way to sort of mitigate risk in any one system, silage or grain. To be fair, for any crop, mitigating risk is the key. Again, I think I'm repeating myself, but back to the basics. So soil test and fertility, when you're looking at a sort of $1,000 a hectare base fert costs $100 on a soil test, all of a sudden very cheap to make sure that you're putting on the right fertilizer and the right nutrients for your system. Establishment, uniform emergence, that goes back to your spray out, your cultivation, and making sure that you have the seed bed that's got, you're looking for a fine fern seed bed, good seed to soil contact. If it requires another $200 a hectare, whatever that cost is to power harrow to get that, you're setting yourself up to capture the yield at the other end. So don't look at that as a cost, you look at that as an investment, because you're giving your system the best chance to flourish. Weed control, all too often I hear, I didn't post a match spray, there was one or two weeds, it didn't matter. But then come canopy, they've had a flush, and all of a sudden, you're losing massive yield because that crop's having to compete with so many weeds. A rule for me is that if you think a crop needs spraying, spray it. If you have to think about it, then the job, you actually already made your mind up. It's very clear cut when it doesn't need it. If you're starting to think that it might need it, more often than not, you just need it, so just do it. And then your CRM, that's again making sure that you are choosing the right hybrid between your plant date and your theoretical harvest date to make sure you're not putting yourself at risk at the other end. Where we can leak value, and this, I guess, is cutting your establishment costs. So again, if you don't do that in the final pass with the cultivating gear, you really can leak some money by having a very poor establishment. You have plants emerging days after each other, becoming false weeds, and all of a sudden you've lost 10% of your final yield. Pushing maturity too far, so I guess that's that habit thing, isn't it? I've always done this, so I'm just going to keep on doing it. Taking a look at that and making sure it is the right choice. If you do go too long, often you lose by leaking yield. Same concept here with population. I've always done it, so I'm just going to keep on doing it. Hybrids inherently have different responses to populations. Understanding what that is, talking to your seed supplier, and really nailing down that population is a very, very important step, especially that's probably for me one of the most important steps you can take, because hybrids actually are very adaptable. So understanding that and making the right choices from the start sets you up for the future. And fertility without a plan, as I keep saying, soil tests, when you're spending as much money as you do on your fertilizer, a test is so cheap. So please, just, all too often I get people asking me, what do I just put? I want to grow 22 tonne. What do I put on? Well, have you done a soil test? Nah, can't be bothered. That's just your stuff from the start, if you ask me. So that key little point, the bottom value is leaked when the spend and the paddock risk are not connected. Now that's a very important line there, for me anyway. You've got to connect your spend with your field, with your system. So I guess a little, probably suck eggs here, but this is the cost versus outcome process. Work out what the goal is the grain, silage, dual purpose. Are you setting yourself up properly? What maturity can safely finish? Again, back to that. You don't want to go too long and put yourself at risk. You don't want to go too short and miss out on that captured yield. So really understanding your environment is the best way to make that choice. Well, make the proper choice with that. What is your main risk? Now, if you've farmed the same farm for 10 years, you'll know when you're prone to go dry. You'll know when the wind comes. You'll know if your disease pressure comes in, if you've got a wet year. Everyone's system is different. Everyone's main risk will be different. And that means that your planning has to be managed around your system. So when you talk to someone else and you've got a different plan, it's actually a great thing. It means you guys are thinking independently and really drilling into what is your limiting factor and how you can mitigate that risk. And then finally, what spend protects that risk. So if you do have low fertility, you're going to have to spend money on fertilizer to bump that up. That's fine as long as you can justify it, as long as you know what you're spreading your fertilizer into. Fine. Seed treatments, that's, or seed and treatment. So, if you know you've got bird pressure, that $50 or whatever it is per bag for Everpel, all of a sudden, very, very cheap when you can save yourself, 10% yield at the other end. Population, again, if you look at it and you can, if you've got really good ground and bump up the seeds a hectare, fine. If you've got really poor ground, you can pull that population back. Again, it's all going to hinge on how you evaluate your environment. And weed control and crop protection, I cannot stress enough. If you think it needs spraying, that's for me the decision made. You should be spraying it. It's very clear cut when it doesn't need it. If at any point you're doubting yourself, that money you spend will not be lost. I can't guarantee it, but I'll promise it. You will definitely see a benefit if you think it needed it and don't do it. More often than not, you're going to be kicking yourself in 3 months' time. I should have spent $100 a hectare, or whatever that cost is. If you think it needs it, it probably needs it. And then, I guess this is again before the season, check your budget and break evens to make sure you understand how much you will be spending and and what your expected return is on that spend. Rethink your CRM choice. So, you might be doing the right thing, but it's worth giving that a really, really good consideration before moving forward, especially in an environment where you've got high inputs and you could risk it all by trying to push yourself too far. And do the basics well. I mean, that's where I think a lot of value, a lot of yield is lost in this industry. We try and cut a corner, we don't spray, we don't do that second pass, we do something that we think is cutting the corner and saving us a cost at the start, but it just costs us so much more at the end. And the key line there, the best Maize system is not one with the most inputs, it's the one where each input has a job and the hybrid CRM and management package fit your system. Very, very key point. And this is my final slide, my 3 take-home messages. Rising costs make yield capture more important, not less important. Protect the basics that spread cost over more tonnes. And that goes back to that graph before about diluting your cost with a higher yield. For grain, CRM is a risk boundary. In most cases above MG3, you've got to really ask yourself, can my ground handle that? Do I have the willingness to carry risk if I'm in some pretty marginal ground, or should I be backing off my CRM to make sure that I'm finishing well, providing a good quality crop and capturing what yield I can? And then thirdly, hybrid population and fertility decisions should be made together around the paddock season and harvest window. Don't be afraid to challenge the paradigm. The paradigm's there to be challenged. You've really got to understand what you're up to and your system to make the best choices. And finally, cost is only a problem when it does not create value. Every major spend protects yield, quality, timing, or risk. And if you can sort of understand that in your own system and justify the spend that's protecting some kind of risk or giving you some kind of benefit, then you're on the right track anyway. And that is me. Any questions?
Thanks, Mike. Team, if you've got some questions, you can either pop your hand up or pop any questions in the chat. In the meantime, I might give you a question from myself. Mike, I can't see any sitting there. Anyone else got the hand up? No. We're looking down the barrel, certainly in our area anyway, of a high intensity El Nino. In terms of the maturity groups, what conversations are you having with growers to manage the drought risk for these coming couple of seasons? I know it's on my mind, and as a seed grower, my question to you is also, as a maize grower, will you have enough seed of those kind of maturity group 1s to 3 for those of us who are starting to have serious thoughts about shortening down which cultivars we use?
Yeah, so great question. There's a lot of worry about it, and the general consensus is everyone who doesn't have really good ground is looking to shorten up to sort of get your flowering, get your crop well into the grain fill or dry down phase before it comes under too much pressure. I can't speak for everyone, but for us, we have in that range plenty of options and plenty of seed. We've had a great year in Gisborne, but it'd be good for you to all talk to your preferred suppliers and make sure that they do have that option for you should you need it.
Right, thanks. That's reassuring. and is that conversation around, hey, your ground is lighter? Have you've got away with it in previous seasons? This year might be the year you go shorter.
Yeah, and and I think I go back to that adaptability thing. Talk to your supplier, and the information that we've all got it around the hybrids that can adapt better to either a drier environment or perhaps you're dropping your population to have less plants fighting for that finite resource of water. The hybrids tend to be able to sort of cope with the lower populations, and if you do get some late season rain or it doesn't come a drought, they can capitalise on that good growing condition. So you're not losing too much of the upside if it does come good, but you do have a good chance of producing a good quality crop if it doesn't. And it's looking towards being a pretty dry year for all of us. So being prepared for that, I think, is the key.
Right. Thanks. Yeah, we had 1.5 mils in the Hortofina in May. So yeah, starting to get a little bit worried. Yeah, we've had rain since, but yeah, it's kind of weird systems here. Hey, thanks very much, Mike. I can't see any other questions there. So really thank you for your presentation today. We will be cutting that recording out for our ENE growers specifically too, because they have asked to see that. So yeah, really thanks for your time. Our next speaker I'd like to invite up is Rene van Tilburg. Rene's based in the Hawke's Bay office, and he's been with FAR for 18 months now. He is the maize research theme leader and is in the final stages of developing FAR's new maize research plan. Rene is here today to talk to us about FAR research on reduced tillage versus cultivation. Rene, over to you.
Good afternoon, everyone. If you'd just bear with me a moment while I bring up the presentation. Don't know about everybody else, but I'm in the Hawke's Bay and it's an awesome day today. Sorry, just waiting for it to load. It's sitting there, but it's taken its time.
Glorious here today, Rene. Glorious. First frost of the season.
Oh yeah, we had a frost too, but nice day now. Can everybody see that?
Yes, I can.
Okay. All right. So thanks for the introduction, Megan. As Megan mentioned, my name's Rene van Tilburg, and I'm the senior maize researcher with FAR. So, okay. So I've got 2 key points today. Okay. Sorry, just. All right, okay. First key point. So what is your cultivation intensity delivering? So I've delivered this presentation before, and I delivered it in Onga last week, and I ended up talking to a dairy farmer prior to presenting, and she said she was really interested in cultivation options. So I said to her, oh, well, you've come to the right place, because that's what I'm talking about. Anyway, I talked to her after the event, and she said, oh, you didn't really sell it to me. So I took the criticism on board. So my message doesn't change too much, but the focus of it does, and the focus is to consider your cultivation intensity. So I was not, in fact, trying to sell no-till over strip-till over cultivation. That's simply not possible for me or anybody else to do, because the decisions that you make around your cultivation system or establishment system, depend on the soil type and the availability of your local contractors or your own resources. But what everybody can look at, irrespective of the establishment system they have, is the degree of intensity in that. And so you'll see exactly what I mean in slides coming up. My other key point is maximize your soil N. So the simple message here is use it or lose it. And Mike had a number of key messages today. And one of those that really fits in exactly here was, does the cost protect your yield? And if not, it's a waste of money. So this is a classic example. So if you're applying more nitrogen than your crop will take up, that's a waste of money. So we can look at how that plays out in the data that I'm about to present. So this slide here is 4 years combined data from the Corson site at Newstead and Hamilton. It's a very forgiving soil. It's an allophanic soil, and it's very forgiving. And so 4 years combined data here shows that there is no statistical difference in yield across those systems. So down the bottom, FC is full cultivation, no T, NT is no-till, and ST is strip-till. So you can see there's very little difference in yield. And I can also say that in any 1 year, there was no statistical difference in yield. So 4 years of data is pretty powerful, showing the same story consistently. And I can also add that the past season, though the data hasn't been analysed, full cultivation did 17.5 tonne to the hectare, no-till did 100 kilos more at 17.6, and strip-till did 100 kilos less at 17.4. So fantastic yields, and the final story will be that 5 years of data out of the site showed no difference between these three different establishment systems. So the key question then becomes, on this soil, and bear in mind it's a forgiving soil, and every soil is different, and every grower's situation is different, but on this site, the key question to ask is, what did the cultivation intensity applied to the full cultivation buy you? And it bought you absolutely nothing. So that's quite clear. But it did cost you labour hours and diesel and depreciation, etc. So if you're in a full cultivation system and you're in a forgiving soil type, then, for example, if you're ploughing with a final power harrow, ask yourself, can I reduce my cultivation intensity by taking out the ploughing, for example? Or you might decide that you've got a lot of trash, so you want to keep the ploughing. So maybe, then ask yourself, should I or can I take out the ripping? If you don't feel comfortable with that, then ask yourself, for example, you might be power harrowing 100 mils deep at 4 kilometres an hour. So perhaps you can shallow your power harrow up to 75 mils, for example, and go a kilometre an hour faster. But question your cultivation intensity, because, as I said, in this situation, the cultivation intensity in the full cultivation system isn't buying you any extra yield. There's no evidence, to be fair, that it's costing you yield, but it certainly isn't buying you yield. No differences in gross margin. I'll press on to the next slide. Small effect on moisture in the no-till system and to a lesser degree in the strip-till system. This is actually pretty common in no-till. Emergence is usually 1 to 3 days slower due to cooler soils, due to lack of cultivation, which traditionally warms soil up, and that delay in emergence translates all the way through to a higher moisture at harvest. What's more interesting here on this graph, though, is the harvest population, and I presume you can all see my cursor moving around. And if we look at no-till, we can see, certainly down here, we can see that it's statistically different, and the difference going across here compared to strip-till and full cultivation, sort of in the order of around about 5,000 plants per hectare. This resonates with some aspects of what Mike talked about previously. So in this case, there's no evidence whatsoever that the lower population resulted in a yield loss. So these plants, this population up here, is effectively surplus to what's needed to produce the maximum yield. So there's potentially a cost saving here. But the degree of that response will depend on the season, and it will depend on your conditions. But for growers, always your sowing rate is something to think about. I don't foresee that FAR is going to do any work in the population space. We've done plenty before. Hybrids change all the time. Growers' circumstances change all the time, and their hybrid choices. But if you're a grower here and you're wondering what your optimum population is, then I suggest you run a couple of strips, 2 or 3 different populations, and try it out. But you have to do it on an ongoing basis, because every year can produce a different result. So you have to think about what your average is over a number of years. So the next slide does change tack quite a bit. So if there were any questions at this point, happy to take them. Otherwise, I will continue on. Okay, so this slide here, I love this slide for 3 main reasons. Before I describe what they, or say what they are, I will just go over what the bars mean. So at the top we can see in blue, this is the yield, and across these 9 treatments, it's very, very flat. So there is actually no statistical difference in the yields across these 9 treatments. And those 9 treatments are a combination of establishment system, FC, ST and NT across here, and 2 cover crops, which is mixed species and oats, and a fallow. And then in red are the varying rates of N applied to these crops. Just bear in mind the scale here, how to do it that way, otherwise it distorts the top line. Now what we can see here is a sustained rate. That's this was in fact only 75 kilos per hectare versus a sustained rate here of 360 kilos per hectare, but none of these sustained rates has had any impact on yield. So how did we arrive at these different sustain rates? Key question. So there was a PMN test done, so potentially mineralizable N, relatively new test that's available. It's giving fantastic results. So for those growers online who are not familiar with this test, happy for you to give me a call or email to discuss and help you with it. And in addition to taking the PMN test, which was one test averaged across all of these 9 treatments, there were individual mineral N tests taken from each of the 9 treatments. So this is a 4-rep trial. So for example, here, this is a composite of the 4 reps. And so as you can see, and so then the yield estimate was 18 tonne per hectare. Just like all growers, we're optimists on what we think the yield will be. So we calculated an 18 tonne crop at requiring 24 kilos of N per hectare, which results in a requirement of 432 kilos of N per hectare. From that figure was subtracted starter N, which was 72 kilos in this trial, leaving a balance of 360 kilos of N to come from somewhere. Now, if we had made no allowance whatsoever for soil provided nitrogen, the crop would have required, I've done the maths for you, the crop would have required $1,000 worth of sustain, calculated at the current price of $1,400 a tonne. So 360 kilos of N works out to, I think, 780 kilos of sustain, and that works out to $1,000 per tonne. So here, the application rate was 75 kilos of sustain, let's call that $100, versus if we'd made no allowance, $1,000 of sustain would have been applied. So there's a $900 saving here if no allowance had been made for soil N. Now, I know most growers make some allowance for soil N, but often it's kind of like an anecdotal allowance. They're doing what they've always done. In this case, FAR has put the figures here. So I mentioned before, why do I love this graph? Well, one of the reasons is that this is FAR walking the walk. So this trial is not a nitrogen trial per se, but FAR has used one of the tools that we recommend growers do use. And as I said, this is a $900 saving here if no allowance had been made for soil N, and over here, which had the highest rate of sustain, even there was around about a $400 to $500 saving per hectare. So it's a staggering amount of money to be saved. Now, there's a couple of elephants in the room. You're looking at this and going, oh, mixed species is the answer to my nitrogen problem. But of course, when you look over here, we see a very different result. So there is no good explanation for why the mineral N on these 2 plots was so staggeringly high, and it was extraordinary. I think it was 200 kilos of mineral N available here. So so don't go thinking that mixed species is the answer to your nitrogen problem, because there's no evidence that it is. So the second elephant in the room is, if you're looking at this and then you go, oh, but in my situation, what if my mineral N test was here? I would have only applied 75 to everything, and there would have been a shortfall here. Or if I just had a 360, or if I just had this result, I would have applied 360 of sustain, and I would have significantly over applied for some of these other plots. So bear in mind that this is a trial, and of course we're taking 9 samples over a very short distance, which shows you the sort of significant differences you can have. But in a grower situation, what would have happened is that you would have taken these 9 samples and you would have composited them, and the result would have been that the recommendation that you came up with was to apply 270 kilos of sustain per hectare. And so the result of that is that over here you would have wasted, unfortunately, a couple $100 worth of sustain, and likely there would have been leaching in the system. And then through here, you would have slightly under-applied. So the total sustain applied would have been no different to what we've done here. It's just that the distribution would have changed. So then the next question as a grower, you'll be thinking to yourself, oh, but I've over applied here and here, so no problem, I'm not going to suffer a yield penalty, but perhaps over here I'm going to lose yield. So I don't believe so. I obviously can't. We don't have the data to prove that because we never tested that in this particular trial. But bear in mind, we did the maths based on an 18-tonne crop, and we only got 16 tonne, and we were allowing 24 kilos of N per tonne. There was a surplus of, we had 48 kilos of N up our sleeve for these higher application plots. And so we applied, so we had 48 kilos up our sleeve, and we under applied 45 kilos of N. So we actually had a balance of 3 kilos mathematically. So the likelihood of a yield penalty, had we just averaged the result, is small. And also bear in mind that as you reach the biological optimum in application, the graph, the response flattens out. So it's not like you fall off a cliff. Under apply 20 kilos of N and your crop's a disaster is not how it works. So in a worst case scenario, there would have been a small yield penalty, which you're unlikely to have been able to have measured. One other key point in this plot here, we only applied 75 kilos of sustain. The key takeaway message here for me is trust your mineral N numbers. So if there had been a lab error or there had been some other problem with this sample and 360 kilos of N should have been applied, we should have seen a significant dip in yield. But that did not happen, indicating to me that the sustain rates for these 2 plots in particular were correct and the mineral N results were correct. To which I would add, in the season just past 25-26, the same methodology was used, and we found across these 9 treatments, we found that the mineral N results were very consistent, and there was one rate of sustain applied, which was 345 kilos per hectare. So somewhere along this line here, which is, so those 2 outliers just completely disappeared. Moving on to the next site. This is near Te Amutu. This is a very different site. This is a silage crop, and there are 4 cover crops. So the first cover crop is veg and tick bean. In the first year, it was only veg, as can be seen in this photo. The second treatment is ryegrass and annual clover strips, and this here is the clover strip upon which the maize is later planted. Perennial clover in here, another treatment. There is no attempt to actually kill this perennial clover from season to season, only to suppress it. So the idea is that there is some regrowth within the crop. And then the fourth cover crop treatment is perennial ryegrass. Overhead shot of the site. The darker green spots are the no-till perennial clover. Lighter green, as in here, will be strip-till, and then this here is a full cultivation plot, which in this case it's severely suppressed the clover, but it does actually make a comeback to some degree. Yield result, so a very different result. So coming back to my key point about cultivation intensity, this tells a very different story. So in this case, full cultivation has brought extra yield. So the cultivation intensity has ended up with a positive return, and the zero cultivation intensity has ended up in a yield penalty, and strip-till, which is somewhere in between, has had an intermediate result. So this result would indicate that increasing your cultivation intensity to some point would improve yields. The grower on this site has been strip-tilling for years. I said to him I was quite surprised that the strip-till result did actually lag behind cultivation, but he wasn't actually surprised by that, so it was in line with his own observation. This site has been cropped for many, many years. It really is a challenging site, and whilst this might turn you off no-till, I would just get you to think about that for a moment longer before you discard that idea. So this is 3 years worth of data, and the first year there was a big penalty for no-till. In years 2 and 3, there was no significant difference in yield between between any of these systems. Though there was a trend, to be fair, for no-till to be lower. So like everybody moving to no-till, all no-tillers have got their story and will tell you about their learning curves and all the things that that they had to learn along the way, and it was no different for far. So the very poor result in year 1 was simply a matter of planting 2 days too late. So timing is much more critical in some no-till systems. The level of skill and knowledge required to get equivalent yield, certainly on a soil like this, is higher. So if you're a grower out there and you're thinking about a move to no-till, learn from everybody else's mistakes, because whilst FAR can put aside 1 year, I could go and have this reanalyzed and drop year 1 out of the equation. But as a grower, try telling that to your bank manager. So that really isn't going to fly. So certainly talk to everybody who's been in the system to learn more. Similar effect on gross margins. Now, a key observation here, though, was, again, thinking about cultivation intensity, and before you discard no-till as not a go, and clearly it's a viable option on the Corson side. The observation that I made here in the season just past is that those plants in the no-till system that were adjacent to a gap flexed considerably, so they were able to respond to the extra space. But a plant can't respond to the extra space if it's limited by the next constraint in the system. So if the next constraint in the system was an absolutely shocking soil, then those plants would not have flexed. And bear in mind that the plants that did not emerge are only 150 mils further away from a plant that did emerge and that did go on to respond to the extra space and flexed. It would indicate that the underlying soil conditions are not yield limiting. So the problem would appear to be quite obviously in the seed zone because they didn't emerge at all, rather than emerge and then subsequently fail. So we don't know exactly what's reducing the emergence, but it's somewhere in the top 50 to 100 mils. And once the plants can get beyond whatever that constraint is, they will go on to produce a competitive yield. But of course, you're down on population. So I would suggest that if that constraint could be fixed, I don't believe no-till on a site like this would be right up here. But there's every indication, I believe, that it could be at least competitive with strip-till. Which brings us back to, okay, good question, Jeff. So we're on the same, we're on exactly the same plots year in, year out. So no-till in the first year is in exactly the same location as no-till 2, 3, 4, 5 years later, and also the same with the cover crops. Don't know if I've missed any other chats in there. Okay. Sorry, what was that, Megan?
That was all the questions so far. We will need to keep moving along though.
Yep. Okay. I'll just focus on the population graph here. So whilst there was every indication at the Corson site that lower populations had no effect on yield, that I would come to a different conclusion here. We can't say that conclusively, but in this case, the population is down around about 10,000 per hectare, so it's pretty significant. And bearing in mind the observation around the flex response observed, it would certainly indicate if this population was up here that some of that yield penalty could be closed. This is the same sort of scenario as on the Corson site. So a PMN test, we had, in fact, there were 4 PMN tests here, one for each of the establishment systems, unlike the Corson site where there was 1 PMN test overall. This resulted in calculating 3 sustain rates. So this was 1 sustain rate similar across these 2 treatments, a second sustain rate here, and then a final sustain rate here. And as you can see, these plots here, or these treatments here, had the lowest sustain rate, but they actually had the highest yield. So once again, no indication that that the lower sustain rates had any negative effect on yield. And on this site, the soil supplied between 130 to 270 kilos of N, so that's the combination of the PMN test and the mineral N test, and that nitrogen was worth from $400 to $630 based on current prices, i.e. $1,400 per tonne. So big savings to be made by doing these tests and doing the math. I won't dwell on this slide. This is simply a decision-making tool if you're thinking about changing your system from full cultivation to no-till or strip-till, things to think about. Sorry, that last slide's not popping up for some reason. It's a bit weird. Okay. I don't know what's happening there. I can see it on my screen, but it's not popping up for you. But anyway, it's the practical outcomes. Just give me a moment because it's so small I can't read it. So let me just bring it up on my other screen here. Okay, so practical outcomes. So no-till can involve a steep learning curve. Strip-till has lower transitional risk than no-till as it is closer to full cultivation. But as Mike said, and I'd like to reiterate the same point strongly, seed bed is critical. So if you're looking to reduce your cultivation intensity, do not do it at the expense of a good seed bed. So good seed placement and uniform emergence remain critical and depend on effective residue management and a uniform seed bed. So the credible performance of no-till should give those in a full cultivation situation the confidence to reduce cultivation intensity. So perhaps take out a disking pass, shallow up your power harrow, perhaps remove a ploughing or a subsoiling, but whatever your particular situation is. Mineral N and PMN testing can help match side dress N applications to crop demand and improve profitability. And finally, the combination of reduced cultivation intensity and the use of mineral N and PMN testing has the potential to save 300 or more per hectare. Those are very conservative figures based on these two very different trial sites. So the savings that we've made or demonstrated exceed $300 per hectare comfortably. That's the presentation done. Are there any questions?
Thanks, Rene. We might keep moving on anyway, and I'm sure there'll be some questions at the end because we're a little bit tight for time. Thanks very much. I'd like next speaker to share his presentation if you can. It's FAR's Sam McDougall. Sam has recently completed his master's degree at Lincoln University, and today Sam's going to talk to us about his FAR research in nitrogen cycling. Thanks, Sam. You able to share there? Give you a moment to do that.
Yes, thanks, Megan. Yes, just won't be a moment. Presentation. Running. Share.
Looking good. Thanks, Sam.
Can see it. Great. Cool. Thanks, Megan. Okay, thanks to the other speakers there, Mike and Renee. So yeah, my name's Sam McDougall. I am a field research officer based in Hamilton. So I've been working with FAR for quite a while, actually, nearly 10 years. But I ventured out to do into the world of academia, and I did a master's. And this is the results of that research that I'm going to share with you today. So yeah, 2 years of good times and hard graft as well. So yeah, some pain, but try and condense that into 10 or 15 minutes. So see how we go. So one of the key reasons that I wanted to do this research on cover crop nitrogen supply to maize silage was at our research site. We've been working with cover crops and legumes and nitrogen cycling for a while. And we were getting some interesting results, particularly from relatively small yielding vetch crops, getting more nitrogen coming through into the maize than we could account for. Sort of piqued my interest, and I wanted to dig a bit deeper. So, and that actually becomes literally digging deeper, digging roots and measuring roots and crowns and things. So some painstaking work going in behind this. So let's dive in anyway. So just a bit of background, bit of big picture stuff. Why do we want to bother understanding cover crop nitrogen supply to maize or maize silage? So big picture, rising nitrogen crop costs, regulatory pressure, and needing to maintain yields and with less inputs, less nitrogen. Big potential with legume nitrogen, but it's hard to manage well. So understanding where that nitrogen's coming from, where it's going in the cover crop and the soil, and how the maize is able to access it. And maize silage potentially has quite a large quantity of N in the crop, so large cost and large potential savings. So I got $676 that I calculated there. So what is my aim? I try to keep it simple. Just understand nitrogen contribution of cover crops in a maize silage system. So I tried to keep it simple, so my research didn't range too far. So hopefully I can stick to that today. So FAR research sites, where we held the research just out of Hamilton. Yeah, if you haven't been there, come and see us sometime. So the key methods for this trial. So I ran the nitrogen down, so I didn't put any nitrogen on the previous maize silage crop. So very low nitrogen site, or in the soil anyway. So this made it easier for me to estimate nitrogen fixation from the legumes and monitor the soil N changes, for example. So while it's not necessarily applicable to a farm situation, it made it easier for me to do my research in that regard. So cover crops direct drilled into maize stubble on 27th of March. No nitrogen applied to the cover crop at all. In early September, the cover crop shoot was mown and removed from the whole trial area. So I think it was 10th of September. Trial area was just power harrowed before maize planting, and then just a small quantity of nitrogen went down in the starter. So 20 kilos of nitrogen went in with the maize starter. So that was the only nitrogen that I applied for the whole trial. So that was just to ensure that the maize got off to a reasonable start, good start, and yeah. So I think we'll keep moving. So just quickly, what were the assessments that I did? So yeah, starting at planting time in March, measured the mineral nitrogen in the soil, went down to 90 centimeters, grew the cover crop, and then at cover crop harvest again in September, I measured the soil mineral nitrogen down to 90 centimeters again, and measured the nitrogen and dry matter in the cover crop, so the above ground shoot, the crown, so 0 to 7.5 centimeter was the crown, and then below ground in the root. And then grew the maize silage, and after maize silage measured the nitrogen in the maize silage crop and the soil mineral nitrogen again. So that gave me a way to monitor where the nitrogen's coming from, where it's going through the two crops and over a whole year. So these are the 4 treatments that I had: annual ryegrass, crimson clover, tick bean, and chemical fallow. So annual ryegrass, I guess, is our control, and fallow was a sort of a control as well. Crimson clover is an annual clover that grows quite well through the winter, and then tick bean, basically favour bean, but just with a smaller seed, easier to manage. So 2 legumes, but one of them is higher yielding, so the tick bean, and then the crimson clover is sort of lower yielding legumes. So just to give me that contrast of the 2 legumes with 2 different growths. So there we are drilling, and there is the trial. So that's the cover crop portion of the trial, the sort of the lighter green, larger crop, if you can tell, is the tick bean there. So that's well ahead of the other 2, grass and clover. So if we get straight into it, here was our yield. So tick bean yielded 8.4 tonnes, so a pretty strong yield. Annual ryegrass 2.4 and crimson clover 3.4, so reasonable yields. The annual ryegrass suffered from low nitrogen, so I could tell that it was pretty yellow, but couldn't actually statistically say those 2 were different, annual ryegrass and crimson clover. But tick bean yielded more than the other 2. So I'll get straight into the nitrogen. Where was the nitrogen in the cover crop? So looking here, you can see tick bean had more nitrogen than crimson clover, and annual ryegrass had the least. And the dark green parts of the bar, they're showing that the majority of the nitrogen was in the shoot of the legume, so above 7.5 centimetres, and this was all removed from the trial to sort of simulate a maize silage system. So annual ryegrass, quite a small amount of nitrogen in the shoot, 28 kgs. And then the amount of nitrogen in the crown and the root was kind of a small, lower level. And actually there was no difference between those 3 treatments. So it's the same amount of nitrogen in the crown plus root component. So that was the material that was worked back into the soil. So going on to the next step, what I could measure in the cover crop was the same for all treatments leading into the maize. So how much nitrogen fixation was I able to calculate? So crimson clover, I calculated 139 kilos. So I got $356 worth written up there. And tick bean, I calculated 232 kilos of nitrogen fixation. So quite substantial numbers, and I was quite happy with that. You can see the little legume nodules there. So a little pink nodule there on this is the crimson clover root. And these are the tick bean active nodules here. So they're a pinky white colour all on the base of the root there. So following the cover crop, an important part of this story is how much nitrogen or mineral nitrogen is in the soil. So we're planting our maize into the soil, and the different winter treatments left a different level of mineral nitrogen for the maize. So annual ryegrass mopped up a lot of nitrogen, so a very low level left, just 12 kgs of N per hectare, so that was down to 90 centimetres. So very low. Fallow had the most, so no crop there to mop it up. That's sort of how much was mineralised. I couldn't really, in this work, I couldn't say there was any leaching, or from what there was no reason to suggest that there was leaching. So in the fallow, I could see it move down the profile, but it was still relatively low level down the profile. And then our two legumes in the middle. So they've mopped up a little bit of nitrogen relative to the fallow, but they're not pumping nitrogen into the soil that is ready for the maize. It's sort of some discussion on whether that is what legumes do. So I didn't see any sign of legumes pumping nitrogen. So what had the biggest impact on cover crop N supply to maize? So it's that soil mineral N after cover crop harvest. So that's what I just showed you. So the what's present in the soil. And then we're going to start talking about cover crop crown and root dry matter level and the C to N ratio of that material. So I guess we'll come around to that, but start putting that in the back of your mind. How much dry matter is in that crown and root, and that C to N ratio of that material. So maize silage yield. What we can see here is annual ryegrass has yielded a lot less than the other three treatments. So despite the so I guess it's a big difference, and we'll unpick that in the next slide. Fallow has yielded slightly more than crimson clover, but tick bean is not different from those other two. So quite a big difference in yield, and we can unpick it in the next slide. So this is where I'm talking about the maize silage N content. So I've calculated where I think the nitrogen in the maize has come from. Okay. So if we start with our 20 kgs of nitrogen starter fertilizer, so that light green bar, so that through the middle there. So that's the same for all treatments. 20 kgs, and then we had our soil mineral nitrogen that we started with. So that's the grey part of those bars right at the bottom there. So you can actually see that annual ryegrass had a negative effect on the mineral nitrogen availability. That's because it started from such a low level, and then through the season it actually went up a little bit. So we actually lost a little bit of mineral nitrogen through the season. And from our crimson clover, fallow, and tick bean, we got a relative amount to what was available in the soil from the start of the season. And this is where it gets different with and this is where I start talking about the root and crown dry matter and C to N ratio. So the dark green bar is how much became available through the season that's not mineral nitrogen. So it's how much cycled from the organic matter or through the season. So we got a lot more from the crimson clover, fallow, and tick bean, and less. So it was about 40 kgs less from the annual ryegrass. So my theory there is annual ryegrass had higher dry matter, had a very fibrous root system, and it had a high C to N ratio. So it actually reduced it created an immobilization of nitrogen effect. So where are we? Yeah, so that is, and overall that's had quite a reduced the amount of nitrogen in annual ryegrass. So overall, and had quite a big impact on the maize silage yield. So how did fallow supply so much nitrogen? So we had 20 tons of dry matter maize silage crop. with just 20 kgs of nitrogen applied. So it's thought like I was saying, no N was leached over the winter. That was I couldn't detect any. I didn't measure any, and therefore there was a higher mineral N coming after fallow, and basically that's the amount of nitrogen that was mineralized through the whole year, less that starter fertilizer. So quite a large amount. How did annual ryegrass supply less than the other treatments? So going back over that, so low pre-maize soil mineral N level. So it mopped up all that nitrogen in the soil, and high root and crown dry matter. So 5.8 tons of dry matter and a high cedar N ratio, so 56. And we usually say 20 to 25 has a neutral effect on mobilization, immobilization, and incidentally that is around what the legume crown and root materials, their cedar ratio was around that 20 to 25 level, so had around a neutral effect on nitrogen mobilization, immobilization. So legume N savings in the maize, just in the maize. So legumes supplied an additional 40 kgs of N. So I've worked that out at 95 kilos per hectare. So, and this is not typically picked up by the soil mineral N and PMN tests. So, which Rene was talking about. I guess this gets a little bit at a higher level. So if you're really getting into your managing your legumes and you're really into your soil testing and predicting and you want to manage and understand how much you're going to get from your legumes, that there's a little bit that we've found somewhere in between those tests here. So it's not that whole 40 kilos, I'm not going to say that, but there is something to work through and something to plan towards there. There is a credit, yeah. So just wrapping up here, so over the full 12 months, how much nitrogen did each treatment supply? So if we start with the tick bean, so from the cover crop and the maize, there was 289 kgs supplied. And along with the crimson clover, the majority of that was in the shoot and it was actually removed. And then annual ryegrass supplied the least. So, and the reason it supplied less than the fallow was because I'm saying it's because of that additional high dry matter and higher cedar N ratio. Crimson clover, it performed well. So that was a 3.4 ton shoot crop, I think it was from memory. So that's actually supplied a pretty substantial quantity of nitrogen there. So I think one of the messages is a smallish legume cover crop can supply substantial quantities of N. And I just want to finish on this caveat: beware of tick beans. I'm aware that my presentation makes tick beans look really favourable, but maintaining the feed quality can be a trick. And on this picture here, you can see there's a dark patch, which is chocolate spot. So there's some diseases and things as well, which is not so, you might have to deal with in other cover crops. So extra management required. Okay, and that's me. I can see Megan's ready and I can see the time is racing along. So I don't know if you want to have questions or you want to keep moving. Megan, up to you. I'm happy.
Thanks, Sam. What we might do is we've got a really brief a brief video to pop on Charlotte sitting in the background there regarding fall armyworm, and then if I think anyone has some questions, then they can ask them once we're finished, and that way if anyone needs to rush off, they can do so.
Kia ora koutou, Ash Mills from Whā here. I'm the Biosecurity and Industry Relationships Officer, and I've been in charge of the Fall Armyworm SFFF project. So one of the questions we've been discussing recently is what happens to fall armyworm populations over the winter in New Zealand. What we know is that fall armyworm does not have a true diapause or hibernation stage. So this is unlike some insects. It basically means that it can't simply shut down and wait for spring. So fall armyworm survival depends on access to suitable host plants and conditions that allow for the continued development or the survival through the winter. So this season, what's been particularly interesting is the really high number of male moths we've been continuing to catch in pheromone traps, and this has been after the harvest of maize crops. So these catches have suggested that there is still considerable adult activity occurring later in the season, so a lot more than some people might expect, especially after those harvests. So if larger numbers of fall armyworms survive the winter, then the implications can be quite significant. We might see earlier infestations in spring, faster build-up once maize and sweet corn emerge, and increased pressure on those early planted crops. And that's really where the high risk is those seedlings in the early whorl stages of plant development. It also means that monitoring becomes even more important. So when we think about possible overwintering hosts, volunteer maize is one of the first places to look. Volunteer maize is highly preferred for fall armyworm compared to a lot of the other grass species that might be available throughout the winter. So think kikuyu grass or your ryegrasses. So if a larva has a choice between volunteer maize and many other alternative hosts, maize is generally going to be the more attractive option. So one challenge is that infestations can be quite easy to miss. Small volunteer plants may appear healthy at first glance, and the feeding damage is often quite a lot less obvious than during the regular growing season. We haven't quite seen the distinct windowing across the leaves. A lot of the time the larvae are just getting straight down into the whorl. And this is really where the destructive sampling becomes important. So rather than looking simply at the plants from above, we need to pull plants apart and inspect the whole whorl and the growing point and the lower leaf sheaths. Frass and small larvae can be hidden deep within those plants. So yeah, please really get in there and do this destructive sampling. I want to emphasize here that the goal is not necessarily to eliminate every single possible host plant, but it really is to break the continuity between one maize crop and the next. So if volunteers are really supporting the fall armyworm populations going throughout the winter, then it is really quite important to reduce those plant numbers. So the first place to start would be at harvest. So reducing the grain losses is therefore one of the most effective ways reducing the number of potential volunteers. Post-harvest management is also quite important. Early control of volunteer maize reduces the length of time that the suitable hosts are available throughout the winter or the autumn and the winter. And also where cultivation is used after harvest, this might also help reduce the survival of pupa. Fall armyworm pupates in the soil, so disturbing the soil surface can expose those pupa to the weather, to predators, and it can reduce the number that successfully emerges at moths to then potentially lay eggs on any volunteers. So in reality, there will be a lot of situations where volunteer maize just cannot be removed immediately or where control options are quite limited. So for that reason, scouting is likely to be one of the most important tools available to you. The autumn and winter behaviour, like we discussed earlier on, may not look exactly the same as we observe in the main cropping season. So assumptions can be quite risky. which is where the regular field inspections and destructive sampling allow us to determine whether the volunteers in that particular paddock are actually supporting significant fall armyworm populations. Importantly, the presence of volunteer maize alone does not justify treatment. However, if scouting does identify a high level of infestation, it does present you with a decision, and insecticide treatments may be worth considering where it is practical, as well as any other mechanical means of control. Just remember, please try and base decisions on what's actually present in the field rather than assumptions. So finally, what might El Nino bring? There's a lot of discussions going on at the moment. Fortunately, we don't have a crystal ball, but let's consider what winter might look like this year. Current seasonal outlook suggests that conditions might be slightly warmer than average in many parts of New Zealand. While this is not a forecast of increased fall armyworm pressure, warmer generally favours the survival and activity of many insect pests. We're going to possibly see fewer severe frosts, which can also allow host plants and volunteers to remain green for longer and extend opportunities for insect survival. It is also important to remember that volunteer maize is unlikely to support an entire overwintering population. I mentioned earlier on the other grasses that might be present in local ecosystems. And these are also quite important. Again, if you do see anything a little bit interesting in some of those grasses, go and investigate. So just to summarise, volunteer maize is unlikely to support 100% of the overwintering fall armyworm population. It does have a preference for C4 grasses, but there are quite a lot of other host plants available in New Zealand. Fall armyworm is polyphagous, meaning it can survive on quite a few different plants. Scouting is key, really is. So if you do have volunteers, it is a great place to start. So please get out there and do some of that destructive sampling. A consideration will be some areas around New Zealand, they do start growing sweet corn in August, sometimes a little bit earlier, but this can be under cloches or it can be open ground. But that is a consideration, especially if you know you're in the same vicinity as a sweet corn grower and you do have potential fall armyworm population. So that leads on to the last point there, which is communication. Please share any of your observations with neighbours and farmer advisors and us at FAR. That data really is quite important and useful, and this does help prepare for upcoming season. It's pretty quick, but quite a relevant topic for this time of year. So thank you, and please, ask any questions. If the team that's present can't answer any, they'll write them down and they'll fire them to me, and I'll get in touch. Thank you so much. Cheers.
That's a great question. Jeff, do you have the answer to that, Rene? How far south are they monitoring? Or Sam might know the answer. Whilst they come in with an answer of that for that. So the scouting, as we said, is the best tool. Doesn't matter how far south you are, Jeff, we can monitor ourselves as well. And so I know it's something that I'm doing at my place. I do have a small amount of volunteer maize in my own crop. So we'll be taking out, pulling entire plants and having a look at those on a regular basis to see how many do have, or if and how many fall armyworm we're seeing. I've not seen any in my crop so far, but as a grower, it's really cheap ways to get out there and have a look at ourselves. And but I'm not quite sure about how many of those how far south the pheromone traps are trapping it. So we can certainly, if there's no one here with that answer, get that answer to you, Jeff.
I don't know. Sorry, Megan. I know during the maize season, that's getting well down into the South Island. So I know they've been monitoring down there during the South Island, but during the winter and where there's maize volunteers, I guess that's a few. Yeah, that sounds like the key.
So do we have any other questions through there? I can monitor the questions through this for Sam or any of the other speakers. if not, we will be sending out a survey to you all. There will be a link coming online for today's session if there is anything else that you want to re-watch. Other than that, I'd like to thank everyone for attending today, and thank our speakers for taking their times out of their day as well to present to us all.